Well, good afternoon, everyone. Welcome. It's a pleasure to see you all here. My name is Ed Schlesinger. I'm the Benjamin T. Rome Dean of the Whiting School of Engineering, and it is really my great pleasure to welcome you to the installation of Jeremias Sulam as the William R. Brody Faculty Scholar. Again, thank you all for being here to help us celebrate this event and to honor Jeremias. And a warm welcome to the Faculty Awards namesake, William Brody. Today is also a celebration of Bill's legacy at Johns Hopkins as the former university president and all that he accomplished both as a faculty member and as president, and we'll hear more about that in a little bit. The installation of a faculty scholar is a particularly wonderful moment in the life of an institution. It allows us to recognize outstanding junior faculty for their scholarship, research, and entrepreneurial thinking. Though he could not be with us today, I want to recognize the generous support of Dr. Bob Cedar, his wife Debbie, and the Cedar family, and all that they have shown and supported our school and in our ability to affect positive change in the world by creating this Faculty Scholar Award. Bob's generosity, the Cedar family's generosity, makes it possible for us to encourage our best faculty to continue doing great research, teaching, and translation. A little bit about Bob Cedar and his connection to the school. We're very proud to call him one of our own. He received his BA from the Krieger School of Natural Sciences at Johns Hopkins University in 1981, his MD at Tufts University in 1986, and completed his residency in internal medicine at New York Hospital Cornell Medical Center. He served as a university trustee and is a current member of the Biomedical Engineering External Advisory Board. He's currently the acting associate director and chief of the cellular immunology section in the Vaccine Research Center in the National Institute of Allergy and Infectious Diseases at the National Institutes of Health. His work focuses on the cellular and molecular mechanisms by which vaccines and adjuvants mediate protective immunity in mouse and non-human primate models of HIV, malaria, tuberculosis, and cancer. His work has demonstrated the importance of the quality of T-cell responses in mediating protection against various infections and the importance of the route of vaccination in generating tissue-resident T-cells for protection against malaria and tuberculosis. In addition, Bob has helped lead the preclinical development of the Moderna mRNA vaccine against COVID-19. And I know that we're not online, right? Or we are online? Okay, we still like vaccines and mRNA. You didn't hear me say that. Bob and his wife, Debbie, support a variety of initiatives at the Johns Hopkins University, including the William R. Brody Faculty Award, the Murray B. Sachs Professorship, the Ruth and Herschel Cedar Scholarship, and the Andrew and Dolores Bozelli Scholarship at the Whiting School of Engineering. In addition, Bob is the son of the late Herschel L. Cedar, a 1939 graduate who earned his degree in economics and went on to lead the Milwaukee Valve Company as its chair and president. Herschel gave back to his alma mater as a trustee for 20 years, during which he advised the Whiting School of Engineering, the School of Advanced International Studies, and the Applied Physics Laboratory. He championed the university's expansion into biomedical engineering, helped to pave the way for our reputation today as the world leader in the field, and I say the world leader in the field. Faculty Scholar Awards, like the William R. Brody Faculty Scholar, not only help us attract, retain, and in this case honor the tremendous accomplishments of a faculty member, they also elevate the status of the Department of Biomedical Engineering, the Whiting School, and the university as a whole. The ripple effect of this level of support can be seen in the caliber of students attending Hopkins and the amazing array of research, discovery, and innovation taking place today. We are so grateful to Bob Cedar, Debbie Harmon, and the entire Cedar family for their generosity and commitment to the Whiting School over many years, and especially at this moment. Jeremias, a number of people are going to speak on your behalf today, but let me be the first to officially say congratulations on this well-deserved honor. We are truly proud to have you as a member of the faculty, so congratulations. And now, before I welcome William R. Brody, Johns Hopkins 13th president, to the podium, I'd like to say a few words about Bill. He received his bachelor's and master's in electrical engineering and computer science from MIT, and his MD and PhD in electrical engineering from Stanford University. As professor of radiology and electrical engineering at Stanford University, his early work in imaging sciences led to advances in ultrasound, computed tomography, digital radiography, and magnetic resonance imaging. In 1987, he joined the Johns Hopkins University School of Medicine, where he was the Martin W. Donner Professor of Radiology, Professor of Electrical and Computer Engineering, Professor of Biomedical Engineering, and Radiologist-in-Chief of the Johns Hopkins Hospital. After 2 years as Provost of the Academic Health Center at the University of Minnesota, he was named President of Johns Hopkins University in 1996. During his tenure, he oversaw 2 successful fundraising campaigns, increased the university's endowment, and increased the university's research and development by 95%. I would round that up to 100%, but that's just me. He also expanded and modernized the research and education facilities on the East Baltimore campus. Among the institutes and centers established during his presidency were the Institute for Nanobiotechnology, the Center for Global Health, the Office of Critical Event Preparedness and Response, the Brain Science Institute, the Institute for Cell Engineering, and the Malaria Research Center. Renowned for his achievements in biomedical engineering and the field of medical instrumentation, he has been a national figure in efforts to encourage innovation and strengthen the U.S. economy through investments in research and education. He has made significant contributions to the fields of medical acoustics, computed tomography, digital radiography, and magnetic resonance imaging. He was an established investigator of the American Heart Association and received the gold medal from the Radiological Society of North America. And we are very, very pleased that he's here with us today, and I'd like to welcome William Brody to the podium.
Dean Schlesinger. I'm walking a little slower because, irony of us, having spent my formative career in radiology, I'm undergoing radiation therapy treatments and looking at things. And actually part of what they do now is they combine the X-ray therapy machine is combined with a CT machine, and they're doing something called tomosynthesis, which is something that Al Makovsky and I worked on in 1978 at Stanford. Although it wasn't possible, we didn't have the area detectors to actually do it. But it's been exciting to see everything. And thank you for your generous and overly generous, hyperbolic introduction. You know, the university president is like a caretaker at a cemetery. You have a lot of people under you, but nobody ever listens. But anyway, when I came to Hopkins, quite frankly, Hopkins, as far as technology goes, was in the dark ages. Engineering was really coming out, having the faculty one year decided to close the School of Engineering in their infinite wisdom, and then it got built back up. And when I came from Stanford, and we had a multidisciplinary imaging lab, and I said, I really want to establish at scale eventually an imaging program. So through Dick Johns, who was the founding, I guess, director of BME, and Don Giddens, who was the dean of engineering at the time, we all agreed that this is something we do, and I set out to recruit the initial people. The first recruit was Elliot McVeigh, whose name is familiar to some of you in BME. The second recruit was Jerry Prince in ECE. And at that time, there was this guy, very smart guy I discovered, but I couldn't pronounce his name. His name was Elias Zerhouni. He was an assistant professor. And at the time, there was MRI, and the department had, before I came, had appointed somebody head of MRI who was a good clinician, but since there was no MRI, nobody really knew much about MRI. and I realized that Elias was special. And he also had an appointment in DME, and so he was my third leg of the stool to establish the imaging program. And since then, all kinds of interesting people. And I tried to recruit some MD PhDs who had done their PhD in science and technology. And the first one of those was Marty Pomper, who some of you know, who has done amazing stuff. He's now chair of radiology at UT Southwestern. So it was just fun to watch it all unfold. And then, of course, after I became president, I had to go try to raise money. And so it took away a lot of time. But Zerhouni, of course, became the director of the NIH. And what you may not know is he's the one who oversaw the startup of NIBIB, the National Institute of Biomedical Imaging and Bioengineering. So it's really the Hopkins connection is carried out at scale nationally. So anyway, now I'm bragging about people I recruited. I'm going to tell you a story about somebody that I didn't recruit. There was this really brilliant guy doing imaging at a place in St. Louis called Washington, what did I say? Washington University in St. Louis. And I tried very hard to recruit this guy, but he's very elusive. And the son of a gun turned me down. His name is Michael Miller. Fortunately, he said no to me, but the people after me were more impactful, I think. And they recruited Mike, and as they say, the rest is history. So it's so nice to see all of you here. And as mentioned by Dean Schlesinger, young faculty are the lifeblood of any university, and those that have a named chair or award not only bring luster to themselves, they bring luster to the donor. And so I feel honored to be named on this, and also that somebody like Jeremias is the new scholar. These are the things that make the university roll, as you know. And so I think all I can say is that you're a brilliant engineer and physicist and scientist and mathematician. And I, of course, am going to follow your work closely. I don't think as an octogenarian I'll be able to understand much of it, but we had a discussion. Imaging is all about inverting a matrix. That's all it is. You can spend a whole career trying to invert that matrix, but anyway. So I just want to congratulate you, Jeremias, and you follow an illustrious path here, and I wish you much success and happiness at Hopkins. Thank you, and thanks again for inviting me.
No, I loved your personality and I loved your vision. What a lineage. I'm just thinking now about your lineage, Jeremias, because of course I was the first Herschel Cedar chair, who Bill knew Herschel quite well. And I was just thinking, because of what Bill said, what we were all doing back then. And there was a famous person in imaging who Bill would have known. His name was Larry Shepp, and an important algorithm had broken because we were all concerned about making emission tomography really work. And of course, you're pointing out that today what we're doing is so different. And I had just received my Young Investigator Award, which Jeremias has just recently received, well, maybe a year ago. And I was hanging around with people like your mentors at the Technion. Of course, I was very influential in terms of intersecting with electrical engineering, and your leadership has really been important in computer science, of course, Mickey. And so it wasn't the right time to come, Bill, just wasn't the right time. And then the Center for Imaging Science was going to be created in your vision here at Johns Hopkins. And Johns Hopkins had just recruited Fred Jelinek. And of course, I knew Fred, right, at IBM, and through that I knew Sanjeev. And it was the right thing to do, is to build a second important center here. Of course, Fred's center was beyond compare. And so in that sense, we follow that lineage, and it's so wonderful to have Bill here, because biomedical engineering wouldn't be what it is today. And of course, he was so close to Murray and of course Herschel, and now Bobby. So I was thinking about how we recruited you, because Bill brought that up. And of course, it's my understanding you got your undergraduate degree in Argentina. But I wasn't quite able to decode UNER properly. Could you say what your university what UNER stands for?
Universidad Nacional de Entre Ríos.
Did everybody hear that? What? Oh, what a beautiful, you see, I've heard that before. So Argentina, and then you went to the Technion. And of course, when we recruited in biomedical data science in 2018, Jeremias was our first recruit in that space, and he's really led that, and it's been very important. And if we look back at the launch of BME 2.0, there were only 2 or 3 principles in BME 2.0. And one of them, which you've really championed with others in our department, is that every undergraduate should be a data scientist in biomedical engineering. And now we have a curriculum that does that, and every one of our students takes it, like they take linear algebra. And of course, you developed that curriculum with Fadil, who's here today. Now, I actually wanted to say the technical words associated to what Jeremias does, because it's really important today more than ever. Jeremias focuses on creating frameworks and algorithms that provide theoretical guarantees and practical tools for robust and interpretable machine learning, ensuring they are not only accurate, but also reliable and explainable. Bravo, Jeremias.
Thank you so much, Mike, and everybody. And it's a little bit surreal to see so many people, so many wonderful friends and colleagues and students, faculties, presidents. It's also a little bit funny because I never really wanted to be a professor when I was growing up. And I think it's mainly because I thought that professors mostly profess things. So basically go around the world telling people what they think and trying to get people to think like they do. Of course, then eventually I grew up a little. I'm still growing up. And I understood that it wasn't really about professing in as much as it was about asking questions and trying to solve really difficult problems. But I think I also understand where the confusion might come from, because when you ask a professor what kind of questions they're working on, explaining that question might take a whole semester. And so it can very easily be confused by professing instead of researching and asking. I'm honestly super humbled and flattered and inspired to be here. And in trying to think what I could possibly share with you and with such distinguished group of people, I started asking what might differentiate, let's say, a good professor from an excellent professor. And when I say professor here, I truly mean not in the strict academic sense, but really in this spirit of inquiry and sort of a career in the sciences, men and women who have done really important things throughout their life to the scientific enterprise. And I think I narrow it down to 4 things, and I wanted to share those 4 things with you. The first thing that I think distinguish good people in science from truly great ones is generosity. And I think precisely Bob Saders and Debbie Harmon's and their families' support and generosity through this award is a very clear example of that. I'm very, very thankful for their support, not just to me, but also to a lineage of faculty who have shared some of these initiatives. Many of them are here today, which is crucial not just for supporting part of the research that we do, but also to put us in this situation where we are truly humbled and inspired by people who have had a very successful career in the sciences, and also to keep reminding us to be generous as we proceed in our careers. The second thing that I think can tell apart someone who's good in science from someone who's truly brilliant is impact. One thing is to solve a very difficult research question by yourself in an office somewhere, and a very different thing is to have those solutions really impact the world of the people around us. And to that effect, I think Dr. Saders' choice of naming this fellowship after President Brody really couldn't have been more accurate and on point. It's very difficult to find someone who has made very deep contributions, not just across a single dimension, but really most of the dimensions of the scientific enterprise, from basic science and research and foundational ideas in inverse problems, to translation of those ideas by instantiating some of these concepts into products and companies that end up having an impact on people's lives, and service. Of course, not just through the presidency here at Johns Hopkins, but really in his leadership roles in scientific institutions and bodies throughout the country, well beyond Hopkins. And for that, I'm really truly honored to be sharing that. Now, I also can't help but sort of feel inspired by President Brody's path. As you heard, he made contributions on the intersection of these fields that were perhaps back then a little bit more disjoint than when they are today. Electrical engineering and radiology and the medical sciences. And like him, I sit a little bit at the intersection of these fields. Like Mike mentioned, my work pertains, on the one hand, designing and understanding algorithms, but on the other, addressing problems that are raised from problems in biomedical imaging, radiology, pathology, and understanding what specific things we can say about them in terms of statistical guarantees, for instance. Now, I don't know if you might know this, but when I was interviewing here already 7 years ago, I was having a blast in one of these visits that I was doing, and I was talking to a bunch of these amazing people who have done amazing things and who would soon become my colleagues. And then I met with Ray Winslow, who was hosting me at that time, and who many of you will remember. And I remember telling Ray how I had never felt more like being in a toy store as a kid. I truly felt like a kid in a toy store. And he smiled and thought for a bit. And then he said to me, that is right, but you should be very careful with the kind of toys or research questions that you choose to play with. And that really stuck with me. And then when eventually I came here to Hopkins, I spent probably the better part of 2 years trying to answer that question. What toy problems, what would be the thing that I would like to play with for the rest of my few years here? And eventually, together with my team, of course, like everybody else, we realized that a lot of these artificial intelligence tools and tools powered by statistics and machine learning, and many of the foundational ideas that we share with Mike, eventually would have an impact that is hard to ignore in today's lives, even more so in the clinical sciences. And I also understood that there are some very important bottlenecks that perhaps differentiate applying these tools in radiology to applying these tools in other problems that might be less sensitive and less risky. And so that's the problem that I decided to study. I we set off basically to understand how is it that we can make these tools that are increasingly so complex and opaque to try to understand them a little bit better, to try to understand what are the driving features that drive their response, and provide some notion of guarantees in these otherwise very, very weak or perhaps hacky systems. We've come a long way since then. Mostly we have understood how to even phrase these questions that perhaps seems a little bit abstract and that sits at the intersection of things that are very different, that have different ways of thinking about problems. We now understand a little bit better when some of these questions can be answered, when these questions can be answered efficiently, or when we can perhaps just give up and there might not be an efficient computable answer to some of these questions. But a lot remains to be said and to be answered. In fact, some of the most pressing and deeper questions in this domain really go beyond just computer science and medical imaging. They start to touch on things like cognitive sciences and theory of communication and regulation and policy, and even increasingly so on ethics. And doing research and asking questions on that space is naturally a little bit more risky from a funding perspective. And so precisely, I think it is on that space and helping us answer those questions that the help and the support that comes with an award like this one will allow us to hopefully put answers to some of these questions. There's a third thing that I think distinguishes great people of science from just those that are good. And those are principles and values. There is a nice quote by Louis Pasteur that I like very much, who said that science has no homeland, but men and women of science do have a homeland. And I think that's very much spot on. We as scientists spend most of our time thinking about questions that sit at the border of human understanding and human knowledge, and we try to answer these questions for all humankind without any borders in mind. But of course, we as scientists are embedded in a society that we influence, and our work is basically promoted and funded by the community that we inhabit. And so I think it's crucial that we keep in mind these principles of freedom, principles of democratic values, principles of generosity that to a large extent have influenced the institutions that promote science and that made science in the United States what it is today. Lastly, I have one last element that I couldn't really ignore when thinking about these questions between good scientists and bad scientists, or let's say okay scientists, and that is the component of our community. So I don't know about you, but I think I do my best work when I'm surrounded by people and colleagues who are not only amazing at what they do and very reputable, but also brutally honest with their opinions, brutally generous with their time and insights and expertise, and very kind in their collaborative spirit. I have found that community at Hopkins. It has benefited me and enriched greatly. And for someone like me who doesn't have any family in a radius of 1,000 miles and even more so kilometers, that community of colleagues and friends have truly become a sort of surrogate family. The same actually holds for my team of students. Probably everybody in this room shares, or at some point has shared, the feeling of discovering and narrowing down an idea in your mind that all of a sudden answers a question that you've had for a while. And then that is an extremely gratifying sense, and we cherish and we sort of pursue that feeling. And that is true, but I have found that it's even more gratifying when this idea of yours that just solved the problem that you had is improved even further by one of your students. And I couldn't be more proud and more grateful to my students who have enabled a lot of the ideas that we have come up with together. That is mostly everything that I wanted to tell you. I'm extremely humbled and inspired by this recognition. I'm not going to profess anymore, and simply thank you all for coming. Thank you for your support, and thank you for indulging me.
Thank you, Jeremias. Thank you for those words. And you can see why we think that Jeremias is so completely deserving of this recognition and this award. We do have this memento, this souvenir of this event for you. So please display it proudly. And with that, I will just say again, congratulations. Thank you all for being here. And please join us for the reception that follows. Thank you.